Hello everyone, welcome back. In this lecture, we're going to be discussing about labor supply in the context of applied consumer theory. So essentially, we have a question that if we want to pay more money or more salary to our workers, how they going to behave? So should we pay more to people so that they work more, or giving more money will cause them to work less? Means that they might take a lot of time for vacation because now they have more money to spend. Okay, so to answer this question in economic framework, let's try to set up some equations. So consumer's budget constraint, how we can write it? It's simply that whatever amount of goods consumer has, okay, and at which price consumer bought that, okay, plus how much is the wage, okay, which we are giving to the consumer, and what is the leisure time or vacation time available is equal to, so this is the income, okay, which is being spent, okay, so spending on goods. And also think about when your employees are not working, they are basically it's a non-work equivalent income. Okay. Now which is equal to M for non-work income, okay, which is the income which they get if they are not, I mean other than the work what they are doing, and at which rate you are paying W multiplied by the total time available. Okay, so think about, in a day 24 hours are there, which is T, and the actual hours where the workers work is actually 8. Okay, so actual work time is 8 in a typical business environment, 8 hours, but the total time is 24 hours. So how much the leisure time would be? 16. Okay. Think about that way. So we can write the budget constraint. Now idea here is that before discussing that, we can also write the budget constraint in another form, uh, which is like total consumption, okay, value of the consumption multiplied by the price. So expenditure, okay, is equal to non-work income plus work income, okay, total income. So both equations 1 and 2 are mathematically equivalent. Now essential idea to find the answer of that question is that is there any way we can separate out this X or goods consumption? And if we can find out what maximizes the utility of the consumption, we can get some hint about the answers of this question listed above. So we can, if we try to write in terms of utility function, we can write a utility function for consumption and for the consumption in the form of leisure time. Okay, so that would be simply by this equation number 3, that whatever is the non-work income available plus the income available which person has worked divided by price multiplied by L. Notice here that this function is in the form of L. We can also write it as HL by equation number 4, since it's the same thing. Now, as we were doing earlier, that if we want to maximize our utility, okay, so as we know that the consumer want to maximize their utility, consumption utility, okay. So essentially the first derivative or first order condition, we want to know the first order condition of the equation for our function HL, and the first order derivative should be 0, okay, for this function to get the optimal value. What do we want to maximize? So think about the slope of the function, 0. and we get the first order derivative in equation number 5. And here the u1 and u2 are nothing but the partial derivatives at the point yz, where what is y is simply m plus w t minus l star. L star is just representing that it is a function of variables, other variables, and z is simply L star. Okay, so at this function, what is the at this point, u1 is the partial derivative with respect to y, and u2 is the partial derivative of the utility with respect to z. Okay, now to know the effect of wage increase, we want to know what is the second order derivative. The second order derivative, if we take it, then we arrive at this equation. It's a very long equation, but nevertheless, don't worry about this big mathematical form, but this is just if you want to take the second order derivative of the first order equation. Okay, now as you can see that this quantity here is less than 0. Now this whole thing and this dl over dw, it will be greater than 0 if and only if this quantity is less than 0. Okay, so basically this part and that part in this equation are equivalent. We can also say that this part is less than 0, and we can rearrange this equation and solve it further, right? And finally we arrive at this equation where T minus L is nothing but the work time, the total time a employee worked, multiplied by W over P, second derivative, okay, plus U12 divided by U1 is greater than 1. Now we can, if we take a logarithm on both sides, and just expand the U11 and U12, we arrive at this equation. So what this equation tells us, that simply the logarithm is a increasing function. So u in t minus l, u1 t minus l would be an increasing function. Okay, or in other words, what it represents, that the L rises with an increase in wages. So simply that if you increase the salary of employees according to this mathematical form, L rises, means they're gonna take more vacation time. Okay, if the marginal utility of goods times the hours worked, marginal utility of the goods times the hours worked is increasing function of L. And as we said, logarithm is an increasing function of L. So no matter what it is, an increase in the wages, okay, would make them to take more vacation time, okay, more leisure time off. Now let's take an example of a Cobb-Douglas kind of utility function. So as we can see in the equation number 8, we have this equation, the utility in the form of Cobb-Douglas, and same thing, we take the first order derivative and solve the equation further. Okay, and we arrive the value of the L, okay, in this form. What it tells us that labor supply increases with the wage. Thank you very much, guys. Hope you liked this short discussion. Thank you for liking and subscribing LeProf on YouTube. Have a wonderful day.